Hey guys, Jason here from Timberfalls, home for CNC creators like you. I want to talk about inlays today. The thing about inlays is depending on what kind of inlay or the size of inlay that you want to do is really going to make a difference between what type of inlay method that you want to use. I'm going to start by showing the most basic of inlay methods, and we're going to go over the inlay wizard, the one that's built into Carveco, and I'm going to show you how to use that tool and some other methods as well. So I'm going to kind of go through several different methods to making inlays. The first one is going to be a very simple inlay. I'm going to use a single letter, and we're going to use the letter M, and I want to transform this to make it really big. Now this is something very simple that you might inlay on a cutting board, or it's just a very basic one item inlay. Now, looking back at that transform tool, it's about a little bigger than 10 by 9. Just to make this easy, I'm going to make it 10 by 9 exactly. And we center the model by pressing F9. Now, going to our inlay wizard, or our inlay wizard tool, is down here, the create inlay toolpath. And when I open up the inlay wizard, we're going to have a couple of different selections. Now, there are several types of inlays that you can do. The most common type of inlay is a pocket inlay, where you create a small pocket where the male piece is going to fit into that pocket. There are other types of inlays, like what are called through inlays, where the inlay shows up on both sides of the wood. And so that kind of inlay, you could actually use the hole here. The two underneath this, the step pocket and the stepped hole, are really just variations of the pocket, except with the stepped pocket or the stepped hole, you can actually tell the program how big you want the shoulder and the shoulder coming down to create this extra area to inlay as deep as you need it to go. Now, the reason that this wizard is okay for simple stuff, but it's not really good for hard stuff, and I'll show all the differences here in just a second. The first one we're going to do is just a female pocket. Now, the female pocket is the pocket in which your piece is going to fit. Now, in inlays, your male piece and your female piece cannot be the exact same distance. There needs to be an offset. Now, the offset is the amount of area between the male and the female where the glue is going to go. For the female piece, we want to determine a depth. Now, the advantage to doing the method that I'm going to show you is you can do extremely deep inlays. And when you have really fine lettering or something, those inlays tend to be shallow. When you're doing a V-carve inlay, those tend to be shallow, but you can do extremely deep inlays. The reason you do this is if you're going to shape an inlaid piece. Like, let's say you want to inlay something 1.5 inches or 2 inches deep. Then you could take that 2-inch inlaid piece and carve something out of it and expose the inlays as you carve through that. And so that's the advantage of having a deep inlay versus a shallow inlay. The disadvantage of this inlay is we're going to just be using end mills. We're not going to be using a V-carve. The V-carve inlays is a different method. So this is the simplest, most basic method. Typically, when you do an inlay, the bit that you're going to use needs to fit in all of the areas of the vector. Now, sometimes you may have to stretch or make your vectors a little larger. Sometimes you may have issues in certain areas, but you generally want to try to get a bit that's going to fit down into those smallest areas. So the smallest end mill that you can use, the better. Now, we're going to use a finish depth of 1/2 inch. Now, the material that I'm going to be doing this pocket in is 1 inch thick. So we can go ahead and come down here to our setup and do a 1 inch thick model thickness. We are referencing the top of our material. Now that we have our finish depth, which is 1/2 inch, the rounded bit cannot get into some of these corners. So it's going to have a small amount of rounding that it's going to do. The Inlay Wizard accounts for this and creates a smooth path inside of this that's going to match our male plug. Now we want to select our bit, and I'm going to select the 1/8 mini Jenny compression bit. This is a really good bit because it'll leave a clean surface at the bottom, and it's also going to leave us a good clean top edge. Now, looking at my step down and step over, I want to make sure that my step down is less than my finish depth, of course, but we want to make sure that we're stepping down gently so that we get the best cut all the way down. Anytime you're doing an inlay, the quality of the cut is really what matters. And so the way that you adjust for this is by adjusting your step down. Generally, I recommend half the diameter of whatever the bit is. So this would be 0.625. And that was because we're going to use half the diameter of the bit to step down. This is going to give us a lot easier chip load when we're going through the material. And it's going to reduce deflection. Deflection is probably the thing that causes the most amount of uneven surfaces in the wall. And it also, deflection is the thing that will create small little gaps at the top as it's trying to carve down. So by reducing your step down, you're reducing the amount of pressure on the entire bit. And that's how you reduce the stress in that cut. Coming down, we're going to also use a roughing tool, because if we use the 1/8 bit, it'll take forever. And so we generally want to try to use a roughing tool that's going to help maximize the amount of time that it takes. And I'm just going to use a 1/4 inch upcut Jenny bit, the Uptown Jenny. I like using an upcut bit on these because it leaves a clean surface. If you use a downcut bit when you're doing inlays, chips are being forced downwards, and so it tends to leave a uneven bottom. So generally you want to use either a compression bit or use a upcut bit. I'm going to be using the compression bit on my finishing pass, so I'm just trying to make sure I keep the surface of the inside of the inlay clean by using a 1/4 inch upcut bit. I'm going to add ramping to this because we will have a plunge, and we already have our material thickness set. Okay, and then we're just going to calculate that, and if we run our simulation on this toolpath, we will have our female pocket. Now you can see where those bits rounded the edge here. Now it also looks like that the vector itself had some uneven issues. I noticed a little spot down here in the corner. Now, before we move on, I would like to add that if you're not going to use this Inlay Wizard, you have to add an offset to either the female or the male plug so that it will fit. If I use the Wizard, and I'm going to show you why I don't like using the Wizard. We've got that toolpath calculated. And this is our female pocket. I'm going to turn off all my toolpaths. Now I'm going to go, for the male on the Inlay Wizard, we have basically a straight. You'll notice that it's going all the way through. And then we have this stepped, which is related to the 2 step pockets. For the pocket and the hole, we use the straight male insert. Now, the thing about the Inlay Wizard is both of these are only profile cuts. So in order to use the Wizard, it's going to cut all the way through the material. So in our male side, because it's a profile cut, the Wizard wants to cut all the way through the material and then hold it in, adding bridges. Now, if I do it like this, then I'm just going to go ahead and we're going to add a finish depth. And we want to cut all the way through the material, so that finish depth is going to be 1 inch. And I want to make sure I get as close to it, so I'm going to use the same 1/8 mini Jenny compression bit. That's the one that we got the closest with in our finishing pass. Now you'll notice there isn't a roughing pass in the male insert And that's because it's just the profile pass that's going to make. Now, before we cut this out, there's a crucial step that you must do anytime you're going to do a male plug, and that's to reverse the image. Now, the way you reverse these images is you use this mirror objects button over here. This button allows you to turn or flip the or mirror this on its axis. So we're going to do it horizontally on the center axis. We click that button and it flips our or mirrors our letter the other direction. Okay, I'm going to add ramping, and we need to add bridges so that when we cut this all the way through, that there's something that is holding it in. Now, the bridges are going to be at the bottom, so it's not really going to matter about those bridges. So what we want to do is just put in some nice bridges, a 1/4 inch that's going to hold this piece in, and we can add them in, or if we click edit bridges, we can actually pick where we want our bridges. And this is the method that I like to use. I like to pick where I put my bridges because it makes it easier when if you ever have to sand them off. Now again, these are going to be at the bottom of our male piece, and so it's not really going to matter. And then once I calculate that toolpath, you can see that our male insert or profile pass was created. I just collapsed that a little. Uh-oh. Wow. Okay. So we had a crash. I should have probably sent them a message. One second, guys. I'll get us right back where we were. We had a crash, and now we're just putting everything back the way I had it. Okay. We have our female pocket, and then we have our male insert. Now, I don't see that little uneven spot on this one. Let's go back. So I'm wondering if that came from our roughing bit. Okay, so this is what I would call probably a graphical error. I don't think this is actually here. And the reason is because if you look at the tool pathing, there's no movement here that changes to make this a notch. I think this is just a graphical error that is in this simulation. These simulations have a amount of tolerance to them. I think I'm only doing the medium resolution simulation. It would probably look better at the higher simulation. See, we're just doing standard. Let's look at it at high. Yeah. See, so that's the difference in just a simulation. Some of those things that I was just looking at are simply simulation errors, and that's not actually going to come out in the cut. But you can see how the female pocket has been rounded, and then the male pocket is also rounded, and that's all done through the inlay wizard. Hold on, let me catch back up on these messages here. Sorry guys. Could you not edit a single bridge to extend it around the carve? What you can do is, instead of cutting all the way through where I did that profile pass, sometimes what you can do is what I call onion skinning. It's where you leave just a little bit at the bottom instead of setting that 1 inch depth of cut, just a few thousandths off of that full depth of cut, and it'll leave like really thin material at the bottom, and that way you don't have to add bridges. That's a way around bridges, but you still would have to cut through that piece of material that's going to be left at the bottom. This is the female plug. We delete the simulation. If I go back to the male part, and instead of 1 inch, let's just do 0.98. And so when we simulate it, removing the bridges, I've left just a little bit of material at the bottom. And then I could take like a sander and sand the bottom. Now remember, the plug, or this male plug, is almost 1 inch thick, but my female pocket was only a 1/2 inch. So when you push this in there, you're still going to have half of it sticking out above the female part, and that's the part you're going to surface off. Okay, so let me show you guys the reason I do not like using this inlay wizard is because the male side in both of these, the stepped and the straight, it requires just a profile pass. And so while this will work on like a really simple like this letter, it doesn't work so well when you get into something that's even slightly more complex. I want to show you what I'm talking about. So I'm going to delete that simulation, and let's just go ahead and get rid of our 2 tool paths here. And let's get rid of this M, and let's bring in something different. I'm going to go over here to my vector library, and I know this skull is part of the Carveco vector library, so everybody should have this. Let's just make it a little smaller. Now, I know right now that this area between these two lines is really small. I really don't need that, so I'm just going to get rid of this outside vector for now and just work with this part of this skull because it's just easier to demonstrate. So for this particular inlay, it's completely symmetrical. So you probably won't need to flip it, although actually there is something going on right here. Let's just delete that. Okay, so we probably will need to flip it because it does look like that this eye is shaped a little different than this one. And if you have any differences at all, this won't work. So we're going to go to our female pocket and I'm going to select my vectors. And for this one, we're just going to go with a finished depth of 1/4 of an inch. And I need to pick a tool. We're going to use that mini compression bit, and I'm using the offset climb starting on the inside. I'm not going to get a roughing tool this time. We are going to add ramping, and our material is still 1 inch thick. Yeah. Okay, we calculate, and this is just going to pocket all of those pieces in this skull. If I simulate, you can see it's created this pocket for all these different pieces. Now, if we try to use the same skull, close this. I'm going to turn off these vectors. Let's go ahead and mirror it around, center it. Now, if I try to use the male insert tool, and I know my material is 1 inch thick, and I'm going to pick that 1/8 inch mini Jenny compression bit. We're going to add the bridges again. Now, notice when I clicked on that, it plans to bridge or profile each one of these teeth. We don't want that. Matter of fact, it's going to profile all of these pieces because it believes that this needs to be cut out. You would want to like onion skin this instead of doing bridges, because the bridges are just going to be too much. So I calculate it, and then if I simulate this, the thing to notice is that because we cut it out, these little pieces right here, basically when that profiled around them, every one of these would have got caught by the bit, and it may cause deflection that would make this part basically would create a mark inside of each one of these, and this would not turn out at all. You'd have a lot of issues with this. The other thing is that it also doesn't pocket out like this skull part. If you had all of these pieces that are in the middle that you don't need, because you just need these parts, the male parts, to fit inside the female. Let's look at the female again. So go to simulation, simulate it again. See, you only needed these parts that go inside of here. This piece here would have been cut out, and then the part that goes around this and the jawbone, that's all one piece. Back to our simulation. Female pocket, male pocket. So that's one of the reasons that I don't like using this inlay wizard, because it doesn't give you the option to pocket these instead. So the better way to do this would be to use a pocketing toolpath. So the one of the advantages of using the wizard, the inlay wizard, is it automatically does all the offsetting that it needs for you to make those two pieces to fit. But when you are not using the inlay wizard, it doesn't automatically do those offsets. And so you have to manually do the offset. So in this case, to do the male piece, let's turn our vectors back on. Now we still have our same female pocket. If I simulate, we still have the whole female part, but we need a male piece. Instead of using our wizard, back to toolpaths, we're going to use an area clearance instead. Now, to do the area clearance, I'm going to need another vector on the outside of this so that we carve the right pieces. Because if we carve it without, we're just going to carve the same spots as we did the female if we just do it this way. So we need another vector to offset it. The best way to do that is to use an offset vector. You can just draw a square around it, and then this would be the size of the material that you're going to cut out for the male plug. But there's a lot of wasted material out here. I don't particularly like to do it that way. I like to use an offset vector because it's always in the shape of what you're cutting, and this will eliminate a lot of wasted cut time. So just creating that offset vector. Now we want to create our pocketing toolpath. So to ensure that the male plug is going to meet the bottom of the pocket, you always want to cut this just a little bit deeper than you did your female. So I'm just going to add 0.52. And so we're just going to go 0.2 deeper. Now we also need an allowance. Now the allowance is going to be the difference between the size of our female pocket and our male pocket. And the allowance number that I use is it's a negative because you want to be cutting closer. So it's negative 0.003. Now, let me talk about allowances and variances for the pocketing of your inlays. Depending on the wood type and hardness, this number may have to be adjusted ever so slightly. Depending on certain types of woods, you may have to adjust this as much as all the way up to 0.007. I've had one go, and I've actually had them a little looser and needed like 0.002. But generally 0.003 when I'm doing inlays is about the correct amount of space that you need. Clamping pressure is essential in these, so you want to make sure that you can really clamp down on that. Now, to do the male plug with our 2D area clearance, we're going to add two tools. First, we're going to add our upcut. I'm going to use the Jenny compression bit. That's going to give me clean sides. You know, it doesn't matter. We're just doing the plug. Actually, let's just do the down cut. We don't need an upcut for this. The 1/4 inch down shear Jenny, because the bottom of this is not important. Just the top edge, the part that's going to fit down into the female side. And then the way the 2D area clearance works is the 1/4 inch bit is going to go around here and get everything that it can. And then we're also going to come back with a 1/8 inch bit. And I'm just also going to use a 1/8 inch down shear bit. And it's only going to go to the places where the 1/4 inch couldn't get. And this is going to help me with my cutting times. I like to use offset, and we're going to start on the inside. I am going to add ramping to these. I add ramping to any cut where the bit is going to plunge into the wood and the first cut's going to be 100%, you generally want to add ramping. And then when we calculate this and simulate, we now have a male plug that's going to correctly fit our female. You can see that all of the skull part was removed, that wide part in between the nose, and the teeth themselves. They're very clean. We don't have those little pieces in the middle of them that could potentially jump off. Doing it this way is a much better way to do your male plug. And this again is a very simple plug using end mills. Do we have any questions so far? Again, the situation depends on how complex your inlay is going to be. These two examples that I just showed you are basic inlays. It's the best way to start doing inlays. With basic inlays, it's hard to mess up these end mills. When you get into the V-carve inlays, it's a little more complicated, and there's a little more trickiness that has to go on to get that to work. But you can accomplish a lot smoother or better details with a V-carve inlay. And we'll go over that now. So I just wanted to show y'all basics of how to do a basic inlay using just end mills. Okay, we're going to go back to our vector library, and we're going to pick something a little more complicated. And I'm just going to use this text because it'll make a great example. This could be a 2-part inlay. You could inlay the background part of this in one type of wood and then come back and do a second inlay inside with the rest of Christmas here. We're just going to get all the letters here real quick. Okay, and we're just going to move those vectors to a new layer. And if I turn that layer off, that's going to give us everything left over. I don't know, a bunch of small little errors or something that came in with that. And then we can move this to a new layer as well and turn that off. That way you can work on one section at a time. Generally, if you're going to do a complex or multi-layered V-carve inlay, you want to put them on different layers. That helps you work on these as you do them. Now, this particular amount of lettering has some really sharp corners. And so this is where the V-carve inlay is going to work best. So the female part of this is pretty easy. We're just going to use a V-bit carving toolpath on our selected vectors. Now, I'm going to be using a limited maximum tool depth of 0.2, and this is because the letters are small. We're going to have our depth at 0.2, and that should give us enough room at the bottom to give us a good seal on all of these letters. Now we need a carving tool. Now for V-bit carving, the thinner the tool that you can use, the better. Now I have used taper ball nose bits, and you can use taper ball nose bit. This is the one that I actually use when I'm doing most of my inlays, and that's the 1/32 taper ball nose. It acts like a V-bit because of how skinny and narrow it is. I also would recommend trying these with the carving liners. Carving liners are very thin, very tall pointed bits, and they're very good for getting into extremely tight lettering or small tight areas where it's going to be hard to get. So if you got something you really need to get like that really tight detail, you're going to want to go with like an 18 degree or 15 degree carving liner. And this is a V-bit with a very, very, very small tip of a certain size. For this one, I'm just going to stick with the 1/32 taper ball nose. And we want to change our step down should be roughly half the diameter of our bit, because we're trying to be as precise as we can. We want to use the very bottom or the slowest of our chip load charts that we can. We want to try to slow this down, as much as possible to take all the impact off of it. And the easiest way to do that is just reducing your step down again. So I'm going to change this to 0.315. We're using a feed rate of 60 inches a minute, plunge of 30. I am going to try to see if a roughing tool is even going to fit in here, but I just used my 1/8 inch mini Jenny compression bit. This may be small enough to where the 1/8 inch is not going to get into anything, but if it can, it will save time. And time is the thing with these inlays that sometimes they can get like really, really long cuts because you're trying to be as less impactful as possible. Okay, so we have our safety, we got our material set. So we're ready to just calculate this. And it did use both the 1/8 inch bit and the 1/32. So let's simulate that. And that all looks pretty good. And that's our female pocket. The female pocket is generally the easiest of the parts of this to do. The male part is where the V-carve or the V-carve inlay gets real confusing for a lot of people. I'm gonna try to make this, I'm trying to explain it in a simple way so you'll understand the mechanics behind what's happening here on the male piece. So we need to, let's turn off these tool paths, and my other layer came back on. I don't want layer 3. Let's make sure we're working in the default layer here. Okay, so I'm going to highlight my vectors here, and we got to mirror this around. So we're going to mirror it on the center. Now, generally your male is going to be you're not going to have a thick piece of wood. So generally when you do these male pieces, you're going to have to reset up your material thickness, but we're going to use the same V-carve tool. Now, if we just carve it like it is, all we're going to do is get a same reverse pocket of the female side. So we need to put a boundary around this in order to be able to carve the male side. So to do that, we again are going to use our offset vectors tool. And notice how I have all of these highlighted. One of the neat things about the offset vector tool is that it'll take all of those vectors and create one single vector out of the outline of it. And again, this is going to save us time when we want to cut this out. Now, I'm just going to tell you that I like to make sure that it's out far enough to where I could put this on a bandsaw and just cut the letters part out. I want to give enough material around here to where I could come with another saw and cut this off, and then I have all of this part standing proud as a male part. I hope that makes sense. Another thing you can do, you can see that our C is really close to the edge over here. We can move this over so that we put most of our lettering in the center of the material. And it's okay that the bit's going to go outside of the material here. We're not really worried about that. So now that we have that flipped around and we have our offset vector, we're ready to do our V-bit carving. Now, in order to, if we just do a regular V-bit carving and we did it at the exact same settings as we did the female, we would not have an offset. Let me see if I can show you that what would happen. We need to set up our carving tools. So we're going to use that same 1/32 taper ball nose. And we're also going to use our 1/4 inch downtown because we want clean edges. All right, we have our thickness set. Now I said that normally the male side is not as thick. So let's adjust for that. Let's say our male is only 1/2 inch thick. Okay, and if I calculate that and simulate it, what happens is this shape is exactly the same as our female. And if you tried to put these together right now, it probably wouldn't fit. It might go in there a little bit, but it probably wouldn't go very far. And that's because there's not an adjustment. So the way to make an adjustment, if you think about a taper ball nose bit or a V bit, the bits are shaped in a V. So the deeper that they go, the more that angle on the V-bit will affect what it's carving. So what we're going to do is we're going to create a start depth of 0.15. And so what that's going to do is it's going to make the bit start down into the wood where it thinks that the top of the drawing is happening is actually 0.15 further down in. So if you think of the female walls, side walls in your female part, it's an angle that goes down and then it reaches the flat spot and then it goes across and it's flat. Okay? Because this is going to be taller, it's going to start down into the depth and then we're going to finish at 0.05. So if you add these two together, 0.15 and 0.05, you're going to get the 2.2 depth of the same depth as your female plug. Now, you probably want to add a little bit to this maximum depth so that your plug is standing a little bit outside of the depth. Because if you did it just exactly this, the male piece and the female piece are going to meet the waste material that's outside of here. So we want to make this just a little deeper, and I would add let's just add 0.55 instead of 0.05. And that's going to give us just a little bit more depth. Now, the offset is created by using a start depth. So instead of having to put in an offset and put that in, we're using the angle of the bit and the start depth to create that offset in the first plunge. And then the rest of that movement is just going to take us to the bottom. Does that make sense, guys? Because that's the hardest thing to understand. It's hard to understand that even though you didn't put in an offset, you're still getting an offset because the V-bit is starting at a depth deeper than the original starting spot of the female size, because the female started at the top. The angle that it made when it went down with that bit is less than this angle because we're starting 0.15 deeper. And had we used a regular V bit, like if you used a larger V bit like a 60 or a 90 degree, the edge of this would have been a lot more evident. The reason that you use a tiny bit is for these tight details. So that is how we V-carve it, or set up the V-carve in Carveco. I'm going to show you another one real quick with the 90 degree. Before I do that, one thing I wanted to talk about that's really important. I can't stress how important it is to have both a flat spool board and a flat material. So when you do these inlays, if your spool board is not perfectly flat, then your inlays can get off from the male side to the female side and can cause gaps on one side where it won't be on the other side. Having a perfectly flat or perfectly smoothed out spool board will allow your material to sit flat onto that. And then I also highly recommend surfacing your material before you start, and that will ensure that everything is perfectly flat. If it's not perfectly flat on both female and the male side, you are going to run into fitting issues. Clamping pressure is key. When you press these two together, the male and the female, I have a hydraulic jack. It's like a car jack, and it's two boards that sandwich it together in a frame, and I just jack that car jack down and smash it, just about as hard as I can get. You gotta be careful with that, because you can crack your material and your wood, especially if you have a lot of that's cut out and a lot that's glued together. If those walls are thin, you want to make sure you have good, even pressure on your whole board. If it's only in one spot, or if it's only in a particular area, that the pressure can actually crack the board in half, or crack your piece in half. And that's something that has definitely happened to me. Beware of that. Make sure you have even clamping pressure when you're putting these pieces together. All right, let's delete that simulation. Let's go ahead and delete our carving toolpaths here. Let's turn off this vector. We have this in a reverse. That's our outer vector. Okay, yeah, this is what I wanted. Okay, so I'm going to show this in a larger V-carve. Now, we need to probably, it is in our material. If I were doing this, I would have shrunk all this down or made sure I had enough material. You can always add a border, like say we want to just add an inch of material. Okay, now we've added an inch of material onto our project here. Okay, so we're going to do the female first, and instead of the 1/32, I'm going to pick let's try a 90-degree V-bit, and I'm going to keep the same 1/4 inch downtown shear for my roughing. The female side we said was an inch thick. We're going to start depth of 0, and our maximum depth is going to be 0.25. So we're going down 1/4 inch, 90-degree V-bit, roughing tool, 1/4 inch downtown Jenny. We calculate. We got to select vectors. And if we simulate that, so it looks like there's a spot right here where the bit was too narrow. See this here? This also too narrow. So that means that our 90-degree V-bit is too large to get into these areas. So let's try a 60-degree, and we'll do the simulation over. Look like we got here, and there's something going on right here. So we know we've got some issues. The other thing we could do, and I talked about this earlier, would be to edit these nodes. So if I hit N and get my node editor, what I could do here is to make this a little bigger. Maybe take this spot here and just move it out some. Same thing here. Maybe take this and make an adjustment. Try to give it a little more room just to see if that would help. And then we simulate that. We still got that issue there, and it kind of helped over here. Again, anytime you do inlays, the tighter the detail, the smaller degree of V-bit you would want to have. So if I go down to a 30, the 30 will definitely get it, and there are no problem areas. These simulations work really good to check out if you're going to have problems. Okay, so now we've got our female pocket, and now we just need to do the male part. We delete our simulation and on our vectors again. Let's turn this toolpath off. We need to mirror this around on center, and let's go back to our toolpaths. Now we're going to create the male, so we need our offset vector again. Go back to toolpaths. We're going to do another V-bit carving, and we want all vectors selected. And we're going to do the 0.05, and we're going to start with a 0.15. We're going to use that 30-degree V-bit, and we're going to use a roughing tool downtown. Okay, we got everything set. And that carved around that lettering to give us our male piece. Now, on the male side, if you get a little bit of stuff at the bottom, that's not really important because it's so far down that's not actually going to be inside of your inlay. But we do have that, because we started at the 0.15, we've created that chamfer or that angle on our walls that is going to allow this piece to fit into the other piece. If you were going a 1/4 inch, let's say the female was a 1/4 inch, I would normally do this at a start depth of 0.2 and then a maximum depth of 0.5. And that would have been a 1/4 inch, say if you had done a 1/4 inch female plug. And that's basically how you do V-bit carving. It's really that simple. So today we've gone over the basic inlay using end mills, the inlay wizard, and we've covered V-bit carving. Any question, guys? Let me know what you think. Is there something else you'd like to see? If you like this content and you're not subscribed, please subscribe to the channel. Give us a like. Always comment. Lets us know, that we're doing okay. And I guess I'll catch y'all on the next one. And let's make bit happen. Thanks, guys. Huge thanks to our Timberfalls Elite members. You folks keep the bit spinning, and we're incredibly grateful for your support. Thinking about joining the Elite? Click the join button here on YouTube or head over to my website timberfalls.us for more details.